Hi, Jeremiah. Hi, Larry.
Hello.
Hello,
Good.
Professor.
Good. You can hear me. That's a wonderful thing. Okay, everybody. Video's on. Video's on, everybody. How we doing? Do we survive the first week of this stuff?
Yes, sir. Yes.
Wonderful. Absolutely wonderful. Is that Larry? Yeah, I got you, Larry. I'm just waiting I got 15 people in here. And I think I'm going to get 18. And I think I have a total of 10, 11, 12, 13, 14, 15, 16, 16 and 16. I think I got 22 in you. Okay. How we doing? We doing okay? Peachy King, wonderful. As good as you can be for an 8 o'clock on a Monday. Monica, did you get my email?
Yes, I got it. Thank you.
All right. Good enough. So basically just make sure you attend them from now on. All right. Did you get to see the video of the chem and physical properties?
No, I didn't see it uploaded.
I'll see where it's at.
Okay.
I know I recorded it. I just don't know where it's at. Okay.
Okay. Thank you.
Okay, ladies and gentlemen. Okay, Mervina. Bethany.
Here.
Thank you, Bethany. Gaith, I saw. Natalie.
Here.
Kylie, I think I saw you in.
I'm here.
Aaliyah. Aaliyah. Corey.
I'm here.
Abhishek.
Here.
Andrew. Andrew, just coming in. Alexis.
I'm here.
Kyle, I think I saw you.
Yeah, I'm here.
Marlene.
Here.
Christine.
Here.
Taylor.
Here.
Monica, gotcha. Adrienne.
Here.
Elaine.
Here.
Jeremiah, I saw. Maria.
Here.
Is Jonathan Roa here?
Here.
Good thing, Jonathan. You were about to get kicked out of the class. You understand that, right, Jonathan?
I've only missed the first class.
All right. The second class, I didn't take roll. All right. Now, you also haven't done any of the assignments.
I've submitted all the assignments that were assigned.
All right. By the time I was taking it, you are now in there. Don't worry about it because you only get kicked out if you miss both weeks. So you're going to be marked in. All right. Everything's cool now.
Okay.
Garris.
Here.
T or Thea?
Here.
Tia. Is it Tia?
Here.
Larry's here and Paige. Paige, I thought I saw you in here. Paige. Okay. So I got Paige and Mervina. Paige and Mervina.
Mr. P, I don't know if I missed my name, but I'm here.
Yeah, I got Andrew. Just as I called your name, you popped into the
Okay.
into the screen.
Okay.
All right, so I've got Paige and Mervina missing. All right, which adds up to 23, which is what we're supposed to have.
Mr. P, I have a quick question.
I'm here.
So I have a doctor's appointment at 9:30. so I'm gonna have to leave around 9:15. Should I just watch it back on the recording?
I would definitely.
Okay, thank you.
All right. If I could find the silly thing. I think I've got them all recorded, but I may have had a problem with one last week. I can't remember. It's all coming back to me. Okay, does everybody see the show screen?
Yes.
Yes.
All right. Now, there are a couple ways to teach density. And one of the easy ways is something called the density triangle. Now, you see there's a line between mass and density and mass and volume. You're seeing that, correct, guys? Shake your heads.
We just see the line of under mass. There's just
Yeah,
a line
so-
under mass, like it's underlined.
There's a mass, then there's an underline, and then density and volume are on the bottom, right? So
Yes.
if you have mass and volume, because there's a line, divide the mass by the volume, you get the density. If you have the mass and the density, because there's a line, divide the mass by the density, you'll get the volume. Or if you have, 1 second, somebody's coming in late. Okay, if you have the density and the volume, they're side beside each other, right? If you had this as an algebra problem, what would you do with the density and the volume then? Instead of being density and volume, say they were X and Y and they're right beside each other. What would you have to do with the X value to
Times
the
them.
Y? Sorry, what?
You times them.
You would multiply them, yes. So if you have the density and the volume and you want the mass, multiply the density by the volume. Let's see how I did this the next slide. All right, you can also do this via the labels, okay? If the mass is in grams and the volume is in milliliters, then in order to get the label for the density of grams over milliliters, you're going to have to divide the mass by the volume. Simple enough. If you have the mass and the volume in milliliters and the density is in grams per milliliter, in order to end up with the mass of grams, you're going to have to multiply them to get rid of the milliliters and leave just grams. Now, if you have the mass and you have the density, mass is in grams, density is in grams per milliliter. If you want to end up with milliliters, what you have to end up doing is multiplying by the reciprocal, or in fact, dividing the mass by the density, you'll get the milliliters. I don't care which way you use, guys. If you can figure out a better way to do this, then God bless you, do it. But you got to be consistent and you got to get the right answers. These are just two different strategies you can use. Easiest problems in the world. You are going to find that you're going to be able to get two of the three things. You just got to follow this formula to get the third. Simple enough, Jonathan? Simple enough?
Yes, sir.
Okay. Now, Jonathan, can you measure a liquid directly? Can you measure the volume of a liquid directly? Let me give you the proper question. Okay, if you have a vessel that's marked, can you pour the liquid in there and read it directly?
Yes, in milliliters.
Yeah, or if it's in quarts,
I mean, yeah.
as long as you have the lines, you can read it, right? So you can measure the volume of a liquid directly. How about the mass, Jonathan? Cup your hands out, and if you have a handful of water, how are you going to weigh that? Can you put that directly on a scale and get a mass?
I mean, you would have to put the scale first, get the weight of the scale, and then you would pour in the liquid, and then you get the weight of the liquid after that.
But you've just made my point, Jonathan. You can't do it directly. You have to employ some sort of a vessel to put the liquid in, correct?
Yes, sir.
So what you're going to do is you're going to weigh whatever you're going to put the liquid in. Generally speaking, whatever you're putting the liquid in is already marked. Okay. You're going to weigh that thing empty. You're going to put the liquid in. You're going to read what the volume is. And then you're going to put that vessel with the liquid in it on the scale. In order to get the mass of your liquid, you're going to get the mass full minus the mass empty. That will be your weight of your liquid. Simple enough, guys?
Yes,
Okay.
sir.
Larry. Okay, an example. I'll be with you in a second, Larry. If I've got my mass without liquid of being 32.643 and my mass with the liquid of 42.893, I subtract the two and I get 10.250. That's the weight of my mass. I divide it by the volume I read and I get 1.00 grams per milliliter. Now, if you have a regularly shaped solid, Larry, can you measure it and determine the volume directly?
No.
You can't?
Well, if it's like a cube, if there's you'd be able to find it that way, but if it's a oddly shaped solid,
Okay.
then you would have to do a different way. But if it's like a cube or a rectangle, yes, you could.
Let's just think about a cube or a rectangle, a cube or a block. Okay? You have a block. What are you going to do to get the volume, Larry?
Length times width times height.
Generally
So
speaking,
measure the length of the width and the height and multiply them by each other.
absolutely. If you've got a regularly shaped object, if you have a cylinder, you're going to measure the diameter of the cylinder and you're going to divide that by 2. And you're going to get the volume of that cylinder by multiplying the height times pi times r squared. It doesn't matter. As long as you have a regularly shaped object and there's a way to regularly measure it and determine the volume, you can get the volume that way. Larry, can you do the mass directly?
Yes, you can just put it on a scale and you'll get the grams. Yeah.
Unlike a liquid, the solid's got regularly shaped. You can put that on a scale. Now, you said something about an irregularly shaped object, Larry. If I was going to get the density of this, you tell me how you're going to do it.
Well, it's quite large, so you need quite a large beaker that has measurements on it. You would fill it with liquid. Obviously, you get the volume from that. And then you would put the object in the liquid, see how much it goes up, take that number, subtract it from the original number with just the liquid in it, and then you would get your volume for that. And then obviously I guess you would weigh it first just in case because of any liquid
You always want
being
to
on there.
You always
Yeah.
want to weigh it first because it's dry then.
Right. Yeah.
And
So
then-
weigh it first, get the mass, and then do the thing with the liquid. You get your volume, and then you can figure out density.
Is anybody confused about what we've been talking about? That was perfect, Larry. Anybody confused? Let me go down. Let me screen down. Let me see. Anybody have any dumb looks? We're good? I'm not seeing any dumb looks. Natalie, focus your camera a little towards you or look into it, okay? Thank you. Gaith, Paige, put your screens on. Gaith.
Hey, Professor, I'm listening to the lecture. I'm utilizing my phone. I'm actually at the pharmacy at the moment, but I am listening to you.
All right, Gaith. All right. Go through an example. If I have a bar with a length of 7.8, width of 4.75, and a height of 1.45, and its mass is 354, what's its density? As Jonathan said, we're going to measure the length times width times height. I think it was Larry, I'm sorry. And we're going to get 53.7 centimeters. We're going to weigh it. It's 354 divided to 2. I've got the density. Irregularly, we're going to take the volume of, we're going to fill the volume of a graduated cylinder usually. Then we are going to note that volume, put the object in. The difference between the two volumes is going to be the volume of your solid. Okay. We good with this, guys?
Yes.
Shake your head,
Yes, sir.
Paige. Pick your Paige, shake your head. Oh, Paige is still sleeping. All right, now get used to this. Chemists like to graph. Okay, they do like to graph because by graphing, one thing you can measure by another thing you can measure. If you can manipulate the equation to a point where you get the equation of a straight line, then you graph the one dimension by the other dimension, and you get a straight line. That straight line will tell you a third value. So if we are going to graph a substance, we're going to be able to graph their mass versus their volume. We're going to get a straight line because that density doesn't change. That line is going to be straight. So that when we do graph it and when we do come up with the straight line, think about it. Slope is rise over run, right, guys? Marvina, right? I don't think Marvina's really paying attention. She just knows to shake her head when I call on her, right, Marvina? Smile, Marvina. Too early to smile. Okay, so does everybody get that? Slope is rise over run. If we put the grams on the y-axis and the volume on the x, then the rise, the label of the rise is going to be grams. The label of the run is going to be milliliters. So when I do the rise over the run, the label is going to be grams per milliliter, which gives us the density. Now, this is a very, very important point. Okay, you notice what I did here. What did I use to determine my rise and my run? Which points did I use?
Two measurements that are
I
pretty
used,
much what, yeah.
exactly. I used the measurement values. Now, ladies and gentlemen, the thing about it is when you're drawing this line, you may have a point here, a point there, a point here, and a point there. When you draw that straight line, what you're doing is you're averaging. You're trying to get the best straight line through all those points so that you have equal distance above and below the line. What that does for you is it allows you to fix any errors. It allows you to average any errors you may have made in your measurements. Does that make sense? If you are just going to use the points, if you're just going to use the points to determine your slope, why did you bother doing the graph? You just wasted all this time making this nice graph because you had the points already. Does that make sense, guys? So when you are doing the slope of a line, what you want to do, you see how you have these boxes, even the tiny boxes? Do you see like right here, the line goes through the corner of that little box? That's what you're looking for. So if it goes through that point right there where I have the crosshairs, all right, there are 1, 2, 3. There are 6 boxes. 6 boxes between the numbered lines going north and south or east and west. So that value is 1.5 divided by 6. Each box is worth 0.25. So all I got to do to get this point is count over 1, 2, 3 boxes. It is 0.75 more than 6. So that point going left and right is 6.75. Going north and south, that is also 6 boxes. But in this case, it is 5 boxes above 40. So I'm going to multiply the 5 by 0.25 and get 1 point. Sorry. Going north and south, this is 20 between them. So if it's 20 between them, and there are 6 little boxes, each little box is worth 3. I've moved up 5 spaces, so I multiply that by 5. I get 16.67. I add that to 40, so my point is at 56.67. Y, and my value X is 6.75. Are we good, ladies and gentlemen? Do we understand how I got the point? I don't know what that was for. Now, when you're graphing, you need to use 70% of the graphing surface. All right. To do this, you need to determine the range you need to graph. So what you're doing by this is you are actually determining the scale. The scale means how much is each box worth. In this case, each one of these big boxes is worth 1.5 going left to right. Up and down, each box is worth 20. So to determine what your ultimate value is, you subtract your high data value and your low data value. You count how many boxes you have. So if I am doing, let's see which one I did. If my high value is 45.9 and my low value is 32.5, I need to subtract those because that's the range that I need to be able to graph. Is everybody with me on that? That is the range. So I got to figure out how many boxes. I sit there, I go to my graph paper, I count the boxes. Say I have 20 boxes. Well, then what I'm going to do is I am going to subtract my high value and low value. That's the range I need to graph. I've got 20 boxes to do the graphing in. I do that math out and I get that each box is worth 0.67 milliliters. Ideally, each box is worth 0.67 milliliters. Is that an easy number to graph?
No.
So what you want to do is you want to kind of round it up to a whole number. You cannot round it down. If you round it down, what happens is you run out of space because your boxes aren't worth enough. So 0.67 is close to 0.75. I'm going to choose that. So each 2 boxes is worth 1.5 milliliters. Each 4 boxes is worth 3 milliliters. It's much easier to graph. The other thing you have to realize when you're using this method, you are not starting at the origin. You are not starting at 0, 0, because if you start at 0, 0, you've wasted a whole lot of your graph paper. You've wasted the space from 0 to 32.5 and 0 to 62.5. You're starting your graph at close to 62.5 and 32.5. So instead of being at the origin, you are a little bit in the first quadrant. Okay, if I have my Y value, Aaliyah, what's my high value in my mass?
For which one?
For the mass,
89.3, is that what you're talking about?
89.3 is my high value. My low value is what, Aaliyah?
45.9.
No.
Oh, 32.5.
All right, you just gave me the mass and you just quoted me the low value of the volume. Is that a good idea?
Yes, I don't know.
No,
No.
because you're not plotting it as mass to volume. I'm sorry, you're not plotting on the y-axis. You're not using volume numbers.
Okay.
So what you are doing is you are taking the high value of the mass and you're going to be subtracting the low value of the mass. What is the low value of the mass?
62.5.
So I'm going to take the 89.3 and I'm going to subtract the 62.5. All right. I need to do that because I need to graph all of those points. So what I'm going to do is I'm going to subtract the 2 and I'm going to divide that by the 15 boxes. I divide 32.5. Wait a second. Hold on a second. I'm sorry. I subtract those two values divided by 15. I got 1.78 grams per box. Again, we can never round this number down. We can make it into a whole number going up. We can't round it down because if we round it down, we're going to run out of graph. So to determine, so we're going to round it up to 2 grams per box. So I've got 15 boxes. So if I start out at 62, my range is going to be 30. I have the capability of graphing up to 92. So I am good.
Why'd you choose 15 instead of 20?
Because that was what my graph paper was.
Oh, okay.
My graph paper was 15 tall by 20 wide.
Okay.
Any questions about choosing a scale? All right. Calculations, what we're doing here. First thing, you're going to have a block. You're going to need to measure length times width times height. And you're going to have to get the volume from that by multiplying the 3 dimensions. Then what you're going to have to do is you're going to have to weigh it, divide the weight by the mass, you will get the density. Second calculation, you have an irregularly shaped metal object. You're going to weigh the metal object. Then you are going to put a certain volume of water into it. You're going to add the solid to it. The volume is going to increase. Subtract the 2 volumes, you get the volume of your object. Divide that into the weight, you get the density. You have a next calculation. You're going to have the mass of a flask, stopper, and liquid. And you're going to subtract from this the mass of the flask and the stopper. That will give you the mass of the liquid. You're going to divide that by the volume that's introduced. If it weighs 76.985 full and empty, it weighs 57.235. You're going to subtract those. If you had a 25.00 milliliter pipette deliver 25 milliliters, to get that mass, you divide the mass by the 25, and that will give you the density. Densities are very, very easy, guys. Very, very easy. Probably some of the easiest questions that you will have. Now, I just ended share screening. What I like to do, I just wasted a half an hour of your time. What I like to do at this point is I like to go through and look at the results section and look at the post lab to make sure that you guys don't have any questions. So we're going to go to the course. Again, in order to get this information, you have to hit course content. And what you are going to do at this point is you are going to go down here. If you go down far enough, after the Vesper lab, you'll see a module labeled student data for labs. Please, ladies and gentlemen, do not, please look at the videos. Please do not use the data in the videos to make your calculations, because those answers are not correct. Please use the student data for labs. You're going to come up here, click on it, and then you're going to scroll down until you get the data. It'll give you everything you need for part A, B, C, D, and you are done there. Questions about the data table and where you get it?
Is this data table also in the lab manual or no?
No. It's
Thank you.
only in the course document, and you have to access it just the way I did.
Is this the one that we print out and then glue into our notebook?
No, you're going to have to take that. No, absolutely not. You're going to have to go to the notebook, and I'm going to be in the lab manual. Lab manual, you're going to have to read this. And we're going to have to go down. Anybody have any trouble submitting the lab book? Okay. Here is the data table. And I've got to move this thing. Here is the data table. Here is the data table. You get the instructions. Okay. You got to, yes, you have to hand enter them. I do not want you to, if you take that student data and you copy it and paste that in your notebook, it doesn't count. You have to hand write the information. And fill that into this data table. Any questions about the manual and the data table?
That data table is what you paste into your notebook, correct?
I don't care. If you want to handwrite something else, that's perfectly fine for me. But it's got to contain all the data that's in here. Fair enough? If you have a better idea, God bless you. All right, so I'm going to get out of here and go to Why did I do that? I gotta move you guys again. All right. And I'm in the home page, so I gotta move you again. Let's take you all the way over here. Thank you. All right, that was the lab manual. If we go into the density experiment, again, look at the video. There are a Word document on significant figures. Guys, these are densities. These are not hard calculations. Pay attention to the data and understand that the data is going to dictate how many significant figures you end up with. Results. Again, this is going to be your first one where you are going to do calculations. So make sure that you put the exact thing that I want into the text box. First question, mass of aluminum bar, mass of glass sphere. Guys, this is not hard. Just copy it over from the data table. You get 10 points free here. Volume of the aluminum bar. You're going to have to take the length, width, and height and show me how you multiply them. So you're going to have to say, for A, length is 6.80 centimeters. Width is equal to 5.30 centimeters. Height is equal to 1.25 centimeters. Multiply those numbers together, come up with centimeters cubed. It has to all be handwritten out there. For B, you have to put final volume in graduated cylinder, whatever that number is, minus initial volume in graduated cylinder, whatever that number is, show me that it's subtracted and give me the final answer, and describe the final answer as being volume of the glass sphere. Okay, now you've got the density, or you've got the volume, and you've got the mass. You got to tell me mass of bar is equal to this, divided by volume of bar was this, equals density of bar. Again, same thing for B, only that you're going to be doing the sphere. Okay, next part, we're doing the density of water. Okay, for the density of water, they give you, I believe, 5 measurements. They want you to do only trial 2's value. So you're going to have to do the mass of the flask with water minus the mass of the empty flask equals grams of the water. For trial 2, show the calculation for the volume. Final burette reading minus initial burette reading. A burette is an instrument that is designed to tell you how much is delivered. So what you do is you read the initial burette reading. Then you open a stopcock, allow some of the volume to go out, stop the stopcock. You now have a second volume. To get the amount of volume that the burette delivered, you subtract the final volume and the initial volume. That will be the amount of water. Then show the density calculation. You've got the mass, you've got the volume. Show the calculation. Now, guys, you need to upload a graph. You lose 20 points if you do not upload the graph properly, which is why I was very strict about the uploading a picture in the syllabus. If you haven't done that, or if you've done it incorrectly, go back. First of all, I would go to the forum. I know there was at least one submission of instructions on how they uploaded their picture successfully. Go back there, because some of you uploaded a picture that was too small. If it's too small, I can't see it. And that is the last part of the results. Any questions here?
Yeah, I have a question about number 4.
Okay.
It mentioned trial 2. Which trial is that?
2?
But what is it involving? Because I'm looking through like the procedure right now, and I'm not sure if is that for the density of water?
Yes, hold on a second. Yes. I'm trying to, okay, I'm going to get out of here. I have to get out of here to get to the other place.
It's on the data table sheet.
That's what I was going to show them. All right, you go to course content. Sorry, got to move you guys again. Again, all the way down to student data. All the way back up. Okay. Now there's going to be you see the density of water experiment?
Yes.
I'm sorry, who's asking the question?
Garrus.
Okay, Garrus. Trial 1, mass of it gives you the empty Erlenmeyer. That's the first thing it does. Trial 1, it gives you the water and flask. Okay. All right, for that burette reading, if you were in the lab, you would actually be doing that. Leave this blank. They're not applicable. You are not going to have to do the volume calculation. All you're going to have to do is do the mass calculation. That question will be based solely on the subtraction of one mass from the other and the density calculation. By trial 2, this is what they're talking about, okay?
Okay, I got it. Thank you.
Any other questions?
Professor,
Mhm.
so from this point onwards, for all results, including on the data tables, on the quizzes, wherever we got to enter a value, do you prefer us to always use the significant number rules?
Yeah.
Okay.
Yes, I am a point thief. One of the easiest ways for me to steal points from you are with significant figures and measurement readings. Do you know why it's the easiest for me?
Easy to read.
It's easy for me because you don't have an argument. If you don't give me the right significant figures, it's cut and dry. All right. So yes, measurement readings and measurement readings and significant figures. For example, if you divide by 5.0, that is an error. You didn't include that last significant figure for your volume. So what in effect you've done is you have penalized yourself in terms of significant figures of your final density. So yes, you would get dinged. If it was 10 points, you'd get dinged 3 points for not putting the proper measurement. Is that understood?
Yes, sir. Thank you.
All right. All right, we're going to go back to table of contents. By the way, ladies and gentlemen, this works wonderfully. Do you see the graph paper that's here? I don't care. I want this graph paper. I want the graph paper that has 15 boxes by 20, 15 boxes width by 20 boxes high. Follow the instructions on the graph paper and print it out. I do not want any other type of graph paper because it's generally, the graph paper you choose is generally too big. I want the real tiny boxes. Okay, density. Post lab. Preview. Corey, don't be so frustrated. I'll get you out of here, I promise, in the next couple minutes.
I'm having fun.
Yeah, I'm sure you are. As much fun as I am.
Probably.
I'm sorry, nothing at 8 in the morning is fun. I took one class at 8 a.m. my entire career. Swore I'd never do it again. Physical chemistry, worst class of my life. Okay.
Ouch.
All right, question 1. It gives you a percent error, gives you the formula. Percent error is always experimental, what you determine experimentally, minus what the absolute value is, divided by the absolute known value, times 100. Okay? Specific gravity of aluminum is 2.70. The 3.29 is what they measured it at. So Corey, what's my experimental density?
The experimental density, and this is 3.29.
3.29, that's what you actually measured it at. 2.70 is the actual known density. Do that calculation, put the answer in there. All right, now it's going to give you simulated problems, and they're based upon what you did experimentally. All right, you have a flask that has a known, empty flask has a known value. You add liquid, and the initial measurement was found to be a certain volume. Excuse me. A liquid was added to the flask from a burette. The initial reading in the burette was 0.85. After the liquid is added, the burette reads 14.80. As I described earlier, you get the volume delivered by the burette by taking the final volume and subtracting the initial volume. So in effect, you take the 14.8, well, I'm not going to tell you. That will give you the volume in the flask. Then you reweigh the flask, it weighs 143.50. That's the flask and the liquid. Determine the density. Next one is going to simulate an irregularly shaped object. You're supposed to figure out what the density is, and because the density of substances do not change, you can use density to identify it. Understand that you will not get an exact answer. In other words, you're not going to get 21. It will be some other number like 20.9. He's trying to simulate an actual experimental choice. And that is it. Any questions? Okay, I got everybody in here today. So We're good. So everybody that's in here right now definitely is staying in the class. I'm going to go after this and mark everybody present so that everybody gets to stay. Woohoo. Any other questions before I cut you loose?
I have a question regarding the lab book. What
Okay.
would we write down for chemical hazards? Would we write down like aluminum and water? Or is there anything that we should be writing for that?
Okay, let me go. Good question. Go through the lab manual as best you can. Where is it? Course content. Okay. What I would do is I would scan the lab manual and kind of flag all of the chemicals that are listed. And in effect, it's going to be a moot point in this particular laboratory. Generally want to go, either the materials are going to tell you or the procedures. And generally, I think they have materials listed. Okay, you got aluminum, glass, and water. That's what I'm seeing here, okay?
Okay.
And literally speaking, you're going to look it up and you're going to say for each one of those, no known long-term or immediate hazards. Or you can list all three of them and put a bracket and say no long-term or immediate hazards. Fair enough?
Yeah.
I'm not trying to make this overly onerous. Any other questions, guys?
Yeah, do we put the safety hazards like under the summary in the notebook?
I would not,
or is it?
I would not put it under the summary. That's something that you want to make the person reading your notebook aware of right away. So I'd put that right after the objective. Anything else, ladies and gentlemen?
I had a quick question.
Yeah.
Since the burette A and B is not applicable to the dry lab, should we still include that in the procedure?
Yes. You had to get the volume some way, so yes, you have to do that. I'm hearing crickets, guys. If there's nothing else, then we can call this a day.
Thank you so much, Professor.
But
Have a good one.
before we go, remember what you have due. All right, today you had to have this, everything safety-wise had to be turned in by midnight last night. Tomorrow night, everything regarding the chem and physical, the results and the post-lab for chem and physical properties need to be turned in tomorrow night, as well as the pre-lab for hydrates. Are we understanding that, guys? Once you get into this rhythm, you're going to be, each lab, you are going to have at least a result and a post-lab and a pre-lab. The other thing is, guys, I give you a week to do the reports. Please give me a week to do the labs. I had all the safety stuff done, except those that turned it in late. I had all the safety reports done yesterday at noon, even the syllabus, multiple attempts. So please give me a week's time before you ask me why it isn't graded yet. It may not, Monday's reports may not get graded until Wednesday. If that's it, guys, I will see you on Wednesday then.
Actually, sorry, I have just one more question.
I'm here.
So because the syllabus is just a little broad with this, but for the lab notebook, you want us to go over, we need a summary of procedure, the data, usually
Okay.
calculations, but for the physical chemical one, I don't think we had calculations. And you said we also need the safety hazards. Is there anything else we need?
Okay. Everything, I've gone over, who's asking the question?
This is Kyle.
Kyle, I've gone over this at least twice now. What I'm going to do is I'm going to direct you to Instructor Notes right now. Do you see that right there?
Yeah.
All right. You click on that. You go up here. The lab notebook is the PowerPoint I gave on that particular subject. I also have an exemplar notebook. Unfortunately, the first page is out of order. But the are you seeing the presentation now? It is out of order. But if you go, this is the first page. Again, objective chem hazards. That's all I'm asking. I'm not for the hazards. I'm not asking you to go into super detail. Then you're going to go back up. That's the last hazard. Then your procedure starts step by step so that somebody could replicate it. Then we're going to get to the third. Procedures are all done. Go to the data table. I just want the data table, no calculations. Separate section on calculations. Then your results. Whatever the objective is, first answer should define, should answer what the objective is. Then you need to go into one error analysis. And you have to tell me how that affected your results. Some water splashed, when I was doing the density of my irregular solid, some water splashed up on the side of the graduated cylinder. When it did, that meant that the volume I actually recorded was less than it should have been. I was dividing by a volume that was less than it should have been. Therefore, my density was increased, was higher than it should have been. That's the kind of error analysis that I want from that. Also in the results, that's where you would do, if you're doing multiple trials where you're expecting the same results, which you are doing in the standardization of a base. I'm going to want a precision analysis, which is known as standard deviation. That calculation is in the PowerPoint. If I give you what the correct answer should be, then I'm going to want an experimental error, which is also in the PowerPoint. Other questions? Kyle, you good?
Yeah, thank you. I was just basing it off, I was originally using the video and the syllabus, and it was just missing a few things. I guess I just missed this slide, but now I'm all good.
Okay. That is Dr. Musgrave's version. I have a few, I know he doesn't put in chemical hazards. And literally speaking, I've instituted that because I want you safe in the laboratory. A colleague suggested it, and I thought it was a good idea. So that's why I do it. And I want you to get used to it because you are, if you have me for Chem 2, you will have to do it then. Any other questions, ladies and gentlemen? Okay, I will see you again on Wednesday. Some of you I will see at 5 o'clock, 5:30 tonight. Take care.
Thank you, Professor.
Thank you. Have a good day.
All right, Professor. Thank you.
Thank you. See
Thank
you.
you.
Professor.
Garrus, how you doing?
Yeah, I'm sorry for asking about when the assignment was due. I didn't even want to know like why they weren't graded. I just wanted to know like when. So I'm sorry about that.
Garrus, you notice I didn't call you out on it. I was basically, I understand, but it wasn't just to you, believe me. It wasn't just you. And there are going to be times, especially this semester, when I make it a little late. I am generally very good. I don't like to have these assignments pile up because it's a nightmare trying to get them graded. So I generally get them done as quick as possible. Okay? And you got, Garrus,
Mhm.
stop being an overachiever. You got 200% on the syllabus quiz. All right?
Mhm.
All right, no problem, Garrus. Nothing was, no ill feelings, all right?
All right. Thank you.
You're
Have a
welcome.
good day.
You have a good day too.